The main objective of any AC or refrigeration system is to remove heat from a space. To do so, we use refrigerants. AC and refrigeration are dealing with lowering temperatures. To do so, we must have a fluid that will have a lower boiling temperature than the desired temperature of the space we are trying to cool. Remember, heat only flows from a warmer substance to a cooler substance. One of the reasons refrigerants are used is because of the lower boiling point that can be achieved. In cooling, we use latent heat of vaporization to cool a space. If you remember from the first assignment on heat transfer, latent heat absorbs and rejects many more BTUs than sensible heat does. If you remember, 1 pound of water will absorb 970 BTUs when changing from the liquid state to the vapor state, and it will reject 970 BTUs when changing from a vapor to a liquid. With sensible heat, you are only absorbing or rejecting 1 BTU. What you need to realize is that whether we are cooling a space with AC or refrigeration, it is the same process. Both systems use identical basic parts. Air conditioning is mainly about comfort, providing cool, low humidity work and living areas, and refrigeration is mainly about convenience, keeping foods cold and fresh. On the slide you see 3 pieces of equipment. The first picture on the left is of a refrigerator freezer. The center picture is of a packaged AC unit. The picture on the right is of a window AC unit. If you look at the different parts, you should notice they all contain pretty much the exact same basic parts. Each piece of equipment has a compressor, an evaporator, and a condenser. One device they all have but is not shown is a metering device. The only real difference about these pieces of equipment is the configuration and size of the parts and what they are set up to do. The refrigerator freezer is designed to provide a place to keep foods cold and fresh. The packaged unit is designed to provide cooling to a large area. The window AC is designed to provide cooling in a smaller space. Let's talk a little about the common parts that all systems will have, whether it's a refrigerator, a freezer, or an AC system. The picture on the upper left is a compressor. It's what is used to pump the refrigerant around the system. You will learn all about the different types of compressors in future classes. What's important for you to understand now is that the compressor is responsible for moving the refrigerant in the system and for compressing the refrigerant and creating the high pressure and high temperature vapor on the high side. Raising the temperature of the vapor allows the refrigerant to have a difference in temperature between the refrigerant and the surrounding air that we are rejecting the heat to. The compressor is also part of the low side. It sucks the vapor from the evaporator and helps lower the temperature and pressure of the evaporator, so we have a temperature difference between the evaporator and the space being cooled. The next picture on the upper left is of a couple different types of evaporator coils. The purpose of the evaporator is to collect the unwanted heat from the space and to cool the air in the space. The picture on the bottom left is of a condensing coil. The purpose of the condensing coil is to reject the heat that the refrigerant has absorbed. If you notice, the condensing and evaporator coil pretty much look exactly the same. When you are looking at a system and you want to know which is which, just remember that the evaporator is in the space being cooled and the condenser is placed somewhere outside the space. Also, the condensing coil is usually enclosed with the compressor. The last picture, the one on the bottom right, is of a metering device. The picture is of a type called a capillary tube. The metering device comes in different designs. Its function is to control the amount of refrigerant that goes into the evaporator. By restricting the amount of refrigerant being drawn into the evaporator by the compressor, it helps lower the pressure in the evaporator. On this slide you can see some different types of refrigeration systems. The picture on the top left is of a commercial fruit and vegetable display. The picture on the Upper right is of a commercial reach-in display. The picture on the bottom left is of the inside of a walk-in unit. Notice the box with 2 fans in it hanging from the ceiling. That's the evaporator. The last picture on the bottom left is of a domestic refrigerator. All of these units are designed differently, but they work in the same manner. On this slide are pictures of some different types of air conditioning units. The top left is that of a packaged unit. It is called a packaged unit because when you order one of these, it comes from the manufacturer with all the major refrigeration components, the piping and electrical wiring of a complete system. The upper center picture is a rooftop unit. It is much like the packaged unit on the left side of it. Most are designed to sit on the rooftop on a base that includes ductwork to distribute the cool air to the conditioned space. The upper right picture is of a residential portable AC unit. They are self-contained units that can be moved around. If you notice in the picture, the window vent attached to it. That is how the heat is rejected to the outdoors. The picture on the bottom left is of a split system. It is designed so the condenser unit is outside and the evaporator is mounted on the wall in the conditioned space. Split systems do not require ductwork. The bottom center picture is of a central AC system. The condensing unit is placed outside and the evaporator coil is placed inside the ductwork of a furnace. It uses the furnace's indoor blower to distribute the air through the ductwork. The picture on the bottom left is of a window AC unit. All these systems, though designed different, work the same as the different refrigeration systems on slide 4. The difference between them is that to get the proper cooling effect, it was designed for use with different refrigerants, pressures, and temperatures. You will learn all about that in your future classes. All systems have a high and low side. If you look at the 2 pictures, you will see the dividing line of the high pressure side and the low pressure side. The metering device and the compressor are the actual dividing points of the high and low side. If you remember from the first assignment, when a substance is changing phase from a liquid to a gas, it is absorbing heat energy. And when changing from a gas to a liquid, it is rejecting heat energy. So to remove heat from a space and reject the heat to an area that does not matter, we need to use the latent heat of vaporization. Low side is where the liquid refrigerant is changed to a vapor, and the high side is where the vapor is changed back into a liquid. So in a system evaporator, which is part of the low side and where the heat is absorbed, is inside the space being cooled. And the condenser, which is part of the high side where the heat is rejected, is placed outside of the conditioned space. To understand how the refrigeration cycle works, you must understand the relationship between volume, pressure, and temperature. All AC and refrigeration systems depend on the pressure differences present in the system. The reason pressure is important is because of the fluid used in the system. The boiling point and condensing point of refrigerants can be lowered or raised with a change in pressure. So if the volume, the area that the refrigerant has to fill, is held constant, and we lower the pressure by restricting the flow of refrigerant, the temperature at which evaporation happens will be lowered. With the lower boiling point, we are able to achieve the desired difference in temperature so that the heat from the space being cooled can be absorbed. If we reduce the volume or the area that the refrigerant has to fill, then we are raising the pressure and temperature at which condensing will occur. And we are able then to achieve the desired difference in temperature so we can reject the heat absorbed during evaporation. Remember, heat flows from warm to cool. So to get heat transfer, you must have a difference in temperature. You want the conditioned space to be cool, have a lower temperature. If the substance's boiling point you are using is higher in temperature than the temperature you desire to achieve in the conditioned space, it will not work. One difference between heating and refrigeration is the language used to reference the measurement of heat transfer. In AC and refrigeration, you will hear the term tons when talking about how many BTUs of heat transfer a system can achieve. A ton of refrigeration is the amount of heat required per hour to melt 1 ton of ice in a 24-hour period. The picture on the upper left explains how a ton of refrigeration is measured. The picture on the lower left explains it in further detail. If you look at the picture on the upper right, it tells you how to convert between different pressure measurements. In refrigeration, to see if a system is operating properly, you must check the pressures. When checking pressures, we use gauges. The pressure reading you get is referred to as PSIG. PSIG is pounds per square inch gauge. It is the pressure difference between what is in the pipe and the pressure of the atmosphere. PSIA is pounds per square inch absolute. It is total pressure including the pressure of the atmosphere. The pressure of the atmosphere is defined as the pressure caused by the weight of the atmosphere. The atmosphere is the air that surrounds the Earth. The picture on the lower right also shows you the different measurements used for pressure. In refrigeration and heating, you will hear the term inches of mercury. In refrigeration, you'll hear it a lot. When servicing equipment, there will be times when you must achieve a vacuum in the system. A vacuum is when we lower the pressure in the system to below the pressure of the atmosphere. If you look at the picture on the lower right, you will notice a picture of a tube sticking into a glass of mercury. It was found that by sticking a hollow tube with one end sealed into a glass of mercury, that the pressure of the atmosphere pushing down on the mercury in the glass would raise the mercury in the tube up 29.9 inches. In the early days, it was common to use inches of water column or inches of Hg to measure pressures. Hg is the periodic table symbol for mercury. Since 1 atmosphere at sea level is 14.7 psi, you would need a column that is 33 feet or so of water. So inches of water column was used for only small pressure readings, and inches of Hg was used for larger pressure readings. If you look at the chart in the picture on the bottom right of the slide, it shows you what the different pressure readings would be using the different measurements of inches of Hg, PSI, A, or PSIG.